We are going to see the second part of the electromagnetic induction. In the previous video, we already told that electromagnetic induction was introduced by Faraday. Electromagnetic induction is nothing but change in magnetic field. Change in magnetic field produces current. This is said to be the electromagnetic induction. Let's see the meaning about the electromagnetic induction. So magnetic means magnetic field, induction means induced, electro means electricity. This means the magnetic field induced to produce induced current which forms the electricity. This is the meaning for the electromagnetic intensity. The electromagnetic intensity is said to be the change in magnetic field produces current. So this was introduced by the Faraday. Let's see the next experiment of the Faraday. So next experiment is he used a primary circuit and a secondary circuit. He take a two circuit named primary circuit and secondary circuit. Primary circuit is connected with a battery and a key and also a solenoid. Now, and the secondary circuit was connected with a galvanometer. This both circuit are in a minimum distance or kept in a minimum distance, but these circuits are not connected to each other. This coil is said to be P coil, and the galvanometer coil is said to be the S coil. Now, when I close the key, current is produced. This current is said to be IP current. When the current started to increase, the first step is to current started to increase. When I close the key, the current started to increase, and the current produces a magnetic field. Change in magnetic field. So this magnetic field induces the S coil so that the galvanometer shows a deflection. That deflection is right side deflection. That deflection source is right side deflection. Due to this deflection, there is a induced current. This current is said to be IS current. This current is due to the IP current produced by the primary circuit, which forms a magnetic field, and the magnetic field induces the secondary circuit coil to produce this current, and also the deflection in the galvanometer. Second, when the current gets constant, there is no deflection. This means when the increased current goes in a constant velocity, this makes the magnetic field. This makes the steady magnetic field. When the current is constant, there will be the magnetic field is produced is also constant. This means the steady current produces a steady magnetic field, and there will be no deflection. And the third is when the key is open. When the key is open, the current started to decrease. Then the deflection showed by the galvanometer. Then the deflection shown by the galvanometer is in the left side. This indicates that when the current is changed, the magnetic field is also changed, which changes the galvanometer deflection. So the current produced in the secondary circuit is also changed. In this, the current is produced opposite to the IP. In this, the current will be same to the IP. This will be in this side. The IP current will be in the same direction. The IP current is in same direction, and the increasing IP is also in the same direction, and decreasing IP is also in the same direction. but the magnetic field induced this IC is different. This is due to the change in IP current. When the IP current increased, the magnetic field lines is also increased, so that the current is opposing the IP current. So IS current is opposing the IP current. When the IP current is decreased, because IP current is decreased, the magnetic field lines also decreased, which makes IS current to attract the IP current, and thus it goes in the same direction of the IP current. This shows that the galvanometer deflection is due to the change in IP current, and this experiment also leads to the wireless connection transformers. The wireless connection transformers are nowadays is used in our day-to-day lives. And this Faraday experiment also tells about the wireless connection of the coil. This coil, the P coil and S coil, does not connect to each other, but it was in a minimum distance, which induces to form a current. So this is the Faraday's experiment. In next video, we will see the Faraday's law and the Lenz's law. Thank you.